All right, good afternoon. So let's see. Looks like it's just you and me so far, Weston.
Yeah,
So, how are you doing today?
pretty good, I guess. It's actually raining here for the first time in a while, so
Oh yeah. So, um, so tell me about your sculpture that you did for Skills USA.
so it's based off the Peloponnesian War, which
Yeah.
was the Delinean League versus the Peloponnesian League, and it was basically over a bunch of land, and so it was Sparta versus the Athenian army, so the
Okay.
Spartan army. So I basically just built a Spartan helmet, and then I put a lot of Greek symbolism on it and stuck swords through it because it looked pretty cool. And
Okay.
yeah, it was a lot of fun building. But
That sounds awesome. That sounds awesome. Well, so did you read the graphic novel of 300 or any of those?
no, I haven't. I should probably pick that up though.
Yeah, it's the the movie's pretty violent. I don't, but it's the um, anyway. But the comic is written and drawn by Frank Miller, who's like a pretty amazing artist.
Okay.
Anyway, as far as like looking at some visual, pretty stunning visuals of that, at least the Spartans and so on. That would be, I would highly recommend that. So anyway, well, there's Jada. How are you doing, Jada?
I'm good.
All right, good deal. Well, so today I actually forgot that Tobias was not going to be here because of his ball game, and but I want to talk to you guys about extra credit. So, but let me just wait till just remind me tomorrow to talk about extra credit because I obviously I want him to hear it too. Okay. So, okay. All right. So today we've got a little bit to do more in 10.10 because I skipped the first part, and then then we're gonna go on to chapter 11. Now I actually downloaded or uploaded and sent to your talent aids all of the guided notes for all of chapter 11. Okay, so that actually should carry us through for the rest of the school year, at least. I mean the the semester. Okay, so that should be up. All right, so we just have a little bit actually to finish up chapter 10. So the on the binomial series. So let's go ahead and get started. Any questions before we get started? Okay. All right, so let's change this. Can you guys see me?
I can see the board, but not
You can't
you.
see me. Okay, now can you see me?
Yeah.
Yeah.
All right. Normally I can see myself. Okay, there I am. All right, let's try this again. Okay. So now I can see the board and then when I get up there and over there, maybe you'll be able to see me too. Okay. So now you can see me on the board?
Yeah.
All right, good. All right. So All right, so the binomial series. So what this is it's kind of a way to, what we're talking about is to use series, a binomial series, and it's an application of the Taylor series. All right, so you might remember in algebra 2, when you would have to multiply out binomials. So like if I had x plus 5 to the 4th, I would write all that out and then FOIL and FOIL and FOIL again. All right, then you learned about Pascal's triangle and a way to get the coefficients. And then in pre-calculus last year, you learned a way to use combinations and patterns to do binomial expansion. Actually, do you do that? I think you do that in Math 152. Okay, so it would have been fall of last year. So I know it's been a while. But what we're going to do is do the binomial expansion for when the exponent is between -1 and 1. So that means it's like a root, like a square root. And see, you don't do that kind of stuff. Okay? And so what we're going to say is 1 plus x to the m is equal to 1 plus the summation as k goes from 1 to infinity of m choose k. So remember, this is like remember like NCR, you can write as with this vertical parentheses. NCR is like n choose r. So this is like m choose k of x to the k. Now, we're going to define, using the combinations formula, m choose k, written like this or like this, is m times m minus 1 times m minus 2 all the way up to m minus k plus 1 over k factorial. Now, we're not going to go that far, so you really don't need to worry about this per se. This is where it's all coming from. But we're going to use that m choose 1 is m choose 2, again applying this formula, is m times m minus 1 over 2 factorial. And then m choose 3, I just kind of ran out of room up here, but m choose 3 should really go up there. Would be m times m minus 1 times m minus 2 over 3 factorial. Or maybe I should give bigger blanks is what I should do. Okay? All right, I'm going to write myself a note. Give bigger blanks on that. Okay. So let's see how. So this is a way to write this binomial expansion as a power series, really. All right. So what we're going to do is, let's say we have 1 plus x to the minus 1. See, we never learned how to do anything like that in algebra or pre-calculus. We never learned how to expand a binomial when you had a power like that. So what we're going to do then is say that m is -1, okay, for the purposes of our formula here. So -1 choose 1, and I'm just using these formulas right here. So -1 choose 1 is m, or -1. -1 choose 2 is -1 times -2 over 2 factorial, which simplifies to just 1. 2 divided by 2. -1 choose 3 is -1 times -2 times -3 times over 3 factorial, which simplifies to -1. Okay? So you all with me so far on the m choose 1, m choose 2, and m choose 3? Okay? All right, so now what we're going to do is set up our power series. And so then we're going to say
I can learn to understand you much better if I can get familiar with the way you talk.
No, you can't. Okay. All right. So let's go back to the formula then. Okay. So this then is the formula that I'm going to write. This is going to be my answer. So I'm going to use 1 for the first term and plus, and that's just going to be a constant. And then the m choose 1 x plus m choose 2 x squared plus m choose 3 x cubed and so on. Okay? So here, then I'm going to take 1, and then my first coefficient was -1, so I'll have -1x. My second coefficient is +1, so I have positive x squared. My third coefficient is -1, so I'm going to have -x cubed plus ... And that's the answer. Okay? So we use the M1, M2, and M3 to get the coefficients. Okay? All right, now, on your paper right above practice 1, if you're filling it out, it says as r of x approaches 0. That was actually from the last section, so you can just cross through that. Okay? All right, so now I want you to try practice 1. So we're just going to do the first 4 terms. All right, so Weston, whenever you've got it.
Okay, so I got 1 plus 12x plus 4x plus 2/3 x plus ...
All right, so you said 1 plus, okay, so you said 12x. So let's go to this. Okay, so 4 choose 1 is just going to be 4. See, the m is 4, right? So whatever m is, m choose 1 is just m. All right, and then you have, so then that gives you 1 plus 4x. Okay, now what did you have for x squared?
The beginning just messed me up, so
Okay.
all my all my factorials are down by 1, but everything else was right, it looks like.
Okay, so yeah, the first one is over the 1 factorial. Oh, I see. And so you did 1 factorial here.
Yeah.
Yeah, so the first one's over 1 factorial, the second one's over 2 factorial, and 3 factorial, and then 4 factorial. Okay? So it's whatever that bottom number there, that's the factorial that goes in the bottom. All right? So Jada, how did you do?
Okay, so I got everything up to the 6x squared. After that, I messed up.
Okay, so the x cubed, okay, so the coefficient here is going to be, so 4, choose 3. So that's going to be 4 times 4 minus 1 times 4 minus 2 over 3 factorial. So that's 4 times 3 times 2. Let's see. 4 times 3 times 2.
Yeah, so like that, I got
So 24 divided by 6 would be 4.
Yeah, 6. Yeah, that I messed up on my.
Okay. So that's 24 divided by 6 equals 4. Okay, and then the 4 choose 4 is 4 times 3 times 2 times 1 over 4 factorial. So that ends up being 24 over 24. Oops. And so then that's your coefficient of the x to the 4th. Okay? So do you understand where you messed up, or do I need to go through it?
Yeah, I got it.
Okay.
Thank you.
All right. So that's it. That's it for the first part of chapter 10, or section 10, and then Euler's identity we did yesterday. Okay? And so that's it for chapter 10. All right? So I'm going to post the I'll post the chapter, the 10-10 quiz and the chapter 10 test probably tomorrow. Okay? All right. So any questions on anything in chapter 10 before we go on to 11? Okay. So chapter 11 is on parametric equations and polar coordinates. Now, the thing that's interesting about this is that that's chapter, let's see, chapter 9, I think, in the trigonometry book, okay, that you went through last year was on polar equations, parametric equations. So the interesting thing about this is quite a bit of chapter 11 here is actually covered in trig, okay? But I kind of feel like it's a good thing to go through it again. But I will say it's kind of interesting because, like, say this first section, there's no calculus at all in it. It's just so like there's a section on trig, and then they'll do some calculus on it, and then they'll do more trig, and then they'll do calculus on it, and so on. And so it's kind of a nice way to end the year. Because it's a good review, because in the parametric and polar coordinates, especially the parametric, are really important at the beginning of Calculus 3. So, and it's not that it's super hard, but it's great to have this review before you do Calc 3. Okay, so I'm glad that we cover it. The first year I taught Calc 2, they told me to just go through chapter 10. And so I didn't teach chapter 11 for a couple of years. And then I realized that I was doing my students a disservice because they were kind of skipping chapter 11. And I felt like, and then Calc 3 would just start in on chapter 12. And so that was totally uncool. So, and because the Calc 3 actually does use the same book. So, anyway, let's go ahead and just jump in. So 11.1 is on parametrizations of plane curves or parametric equations. All right, so a parametric curve, if x and y are given as functions of t, x equals f of t, y equals g of t, over an interval of t values, then the set of points x, y, f of t, g of t, defined by these equations, is a parametric curve. The equations are parametric equations for the curve. So, in other words, parametric equations are equations in terms of a third variable, which is often t. So, like in physics, you have, say, functions of time. And so you break down an equation, use like the vertical component of position and a horizontal component, both as functions of time. And so they're two variable equations in terms of a third variable. And so that's what makes it a parametric equation. Okay. So, like for example, in baseball, there's probably no sport that uses math more than baseball. And matter of fact, they have what they call analytics in baseball, where they will dissect every aspect of a player. And like if a player hits, and so because let me give you an example of how parametric equations fit into baseball. See, in baseball, it's not about just hitting the ball the highest. Okay, that's not the best home run hitter. Okay, that could be a pop fly. So if this graph represents the height of the baseball, well, it's not just the highest that's always the best. Okay, or if this one represents the horizontal distance, okay, so hitting a line drive to center field, that's not always the best. What you want is a combination of height and distance. And so they'll analyze a player, breaking it down, the height of the baseball over time, the distance. And so they'll actually work on the exact angle that batter should hit the ball, that the ball should come off the bat in order to hit a home run. All right, and so there's all kinds of things that they look at. And so these are functions of time. And so if you take any position, so this isn't a baseball, but just some, maybe this is the position of a drone flying over a battlefield. Well, they need to keep track of its horizontal position and its vertical position. Actually, in the situation of a drone, they would have a third position. So, like an X, Y, and a Z coordinate. Okay, but that's more for Calc 3. Okay, we're not going to worry about that. All right. So the way that a parametric equation is graphed is that you actually have like your t values. And so usually, like I said, in physics where time is positive, a lot of times we'll start our t with zero. And then you're given a function of x and y. And so based on these values for t, you plug into the x equation and the y equation. All right, then when you graph it, see, you actually have, I do have some negatives here, just to kind of show you the graph. But what you do is you have all three variables are going to be represented in your graph. So at t equals -2, okay, the x value we got was 4 and the y value was -1. So you graph the point 4, -1. Okay, and then at that dot you label that x equals -2. Okay, then at -1 we have the point 1, 0. So you graph that. Now the difference is that when you go from one t to the next, you actually draw these little arrows indicating which way that your graph is going. Okay, so like if you watch like the Weather Channel, you know, they'll actually show the wind as a parametric equation because they'll show its position over time and they'll have these little arrows. Okay, all right, so says sketch the curve defined by these two equations. All right, now I haven't given you the t values, but let's go ahead and use those for the t values. So plug them into the x and the y and see if you can graph them. Okay, so let's see if you got it. So the graph looked somewhat similar to the last one. Let's see, t squared, t plus 1. This was t minus 1, so it's just shifted a little bit. But you have that basic look. All right, so any questions? So as you're going from your different t values, you draw the arrow showing which direction that you're going. Okay. Now, I want to show you, just in case you forgot, that you can actually graph parametric equations on the calculator. So let's show you how to do that. All right, so, okay, what you do is you go to mode and then switch from function to parametric. Okay. All right, then the next thing you want to do is do your window. Okay. So see the window asks what's your T-min and T-max in parametric mode. So our T-min is -1, our T-max is 3. Okay. And that should do it. So now if I graph it, see, then it shows me the graph. Now, the only thing it doesn't do is it doesn't put the arrows on. And most like physics teachers will want you to put the arrows on, or if when you're graphing a parametric equation. All right. All right. So Weston, you were wanting to do physics, right? Did you guys do parametric equations?
We might have. It's been so long since I took the physics class.
Okay. Well, so one of the things that they do is they'll actually separate the horizontal and the vertical components, so that when they do the forces and everything that act on an object, that they'll have the horizontal and vertical components separately. So that's kind of,
I do remember that actually.
yeah. So that's kind of more with vectors, but this is kind of a way to kind of include that as well. All right, so now I'm going to show you how to get the parameter, but first I'm actually going to show you how to eliminate the parameter. So to eliminate the parameter t, you solve either equation for t. Then substitute into the other equation, and then simplify. All right, so let's show this. It says identify geometrically the curve in example 1 by eliminating the parameter t and obtaining an algebraic equation in x and y. Okay, so again, what I want to do is solve for t in one of these equations. Now, you can actually pick either one, but see, this one I would have to do a square root, whereas this one I would just have to subtract 1. So I like this one better. So I'm going to just subtract 1 and get t equals y minus 1. Then I take and I plug that in for t in the other one, and I get x equals y minus 1 squared. Okay, so that's it. I've eliminated the parameter. Now, you might remember this is going to be a parabola, but it's sideways because it's the y that's squared, and the vertex is at 0, 1, the hk. Okay. But this is a right opening parabola. All right. Any questions on that? Okay, so try practice 2. All right, so Jada, when you've got it.
Okay, so I got x equals y plus 1 squared.
Okay. All right, so then what kind of figure is that?
The parabola.
Yep. Which way does it open?
The left.
It's also to the right because it's positive y squared. So this opens to the right. All right. Okay, so the standard form of the equation of the unit circle is x squared plus y squared equals 1. All right, now I'm going to come back to that in a second. But see, what if these were my parametric curves? See, I would have let's see, y equals so x of t equals 5 cosine t. Well, let me delete that. Okay, there we go. So 5 cosine t, y of t is 5 sine t. Okay, so when I graph, okay, so actually this should be a circle. The problem, what I've got here is when at the window, see, I've got it, the step is too big here. See, we want to graph more than every 1 radian or whatever. So, so I'm going to put 0.1. So now when I graph, it's, let's see. Oh, the t value, again, going back to the window, I had the t going from -1 to 3. Okay. Let's see. What mode am I in here? I'm in radian mode. So if I want to go all the way around the circle, I want to set my angle to go from 0 to 2 pi. So set my t to go from 0 to 2 pi. Now when I graph, okay, but it still doesn't look like a circle. And that's because the screen is stretched. So to kind of compensate for that, I do zoom square. And why is that not working? Zoom 5. Okay, there we go. So that makes it look circular when you do zoom square. Okay. Now, so go ahead and see if you can graph that in your calculator. So that is actually, well, okay. So what you actually have graphed there is the unit circle. Okay. So if you ever forget like a sine value or a cosine value, see, you can just type in like x equals and then, or t equals, and see the x value is the cosine. So if you like, you put in pi, see the cosine of pi is -1 over here. And the sine of pi is 0. So you can trace, or you can enter in any value, or you can do a table or whatever, and have the calculator give you any trig value you want from the unit circle. Okay, so we'll zoom in a little bit there. Okay, so there's the unit circle. So what I'm saying is to pick a value for t, an angle. So let's say you trace, and see at 0 radians, the cosine is 1, the sine is 0. So let's say you want to know, well, what about pi thirds? So you could just do trace. Let's see, so trace, and then just do second pi divided by 3. And so it takes you up there. So the cosine of pi thirds is 0.5. The sine is 0.866. So that, which is radical 3 over 2. Okay? So it's kind of cool that you can, build that in, have the unit circle in there. All right, any questions on that? So the unit circle is an example of a parametric equations, because the x value is the cosine of the angle, the y value is the sine of the angle. So the angle theta or t or x or whatever, that's the third variable. Well, we wouldn't use x, but okay. All right, so the graphs of parametric equations can be used to describe the motion of an object. So what I'm saying is that then, like, the x value is usually considered the horizontal motion, and the y value is the vertical. Okay, so let's say that we're moving along a parabola t. So we're starting time at t greater than or equal to 0, and these are my parametric equations describing the motion. Okay, so I can either graph it as a parabola, or I can eliminate the parabola and graph it. Okay, it doesn't matter. I'm still going to get the positive part of the parabola. Okay, I think it's easier, since it's already in parametric, just to put it in there and graph it. Parametric. Then what you can do is trace along this line, and then at any time, the x value will tell you the horizontal distance, the y value will tell you the vertical distance. The object is gone. Okay? So let's try that for practice 4. Okay? So first, put in those values, have the t start at 0. And then see, you might be asked a position question like, after 1.5 seconds, what are the horizontal and vertical positions? Okay, so you would, Okay, so you put the equations in. Okay, when you do your window, you want t to start at 0. Okay. All right. Now, so there's the graph. Okay. Everybody get the graph? You guys get the graph okay? Okay. Jada got the graph. So then to at any time, so let's say at what did I say, at 1.5 seconds. So if you do trace 1.5, then see the horizontal distance it's gone is 1.5, the vertical distance is 1.225. Okay. And so we can use that parametric equation then to break down the horizontal and the vertical at the same time. Okay? All right. Well, any questions? All right. So that's a good place to stop. We'll pick it up from there tomorrow. And remind me at the beginning to talk about, assuming you're all three here tomorrow, remind me at the beginning to talk about extra credit. Okay? All right. Well, have a great day. Thanks for working hard. We'll see you tomorrow.